All right. This is considered Atwood's machine. This is a massless, frictionless pulley. If M2 is greater than F1, this thing's going to accelerate in this direction. So I'm going to say that this is kind of like the positive direction. Up for him is positive, down for him is positive. I can't say up for both is positive because then the accelerations would cancel out. So up for him is positive, down for him is positive. So free body diagram for this guy, I've got his gravity, and then I have tension, which is going to be bigger because he's going to accelerate up. This guy's heavier than him, so he's going to accelerate down. So if he's heavier, his gravity has to be bigger than this guy's gravity. Well, first of all, the tensions are going to be the same because it's the same string, and this is a massless, frictionless pulley. Let's take my word for it for now. So I draw this tension the same size, and then gravity has to be larger because he's going to accelerate down. Going to have an acceleration this way. So this force of gravity is the smallest, the two tensions are the same, this force of gravity is the largest. And this force of gravity 1 is going to be M1 times G. That's how you, the mass times 9.8, that's how you get weight. And this is going to be M2A. And so usually, not always, but usually we find the acceleration by doing F equals ma for both. But before I do that, this would be sum of the forces on 1 equals m1a. This guy here would be sum of the forces on 2 equals m2a. And then for both, I'll write it over here, sum of the forces on both is m1 plus m2a. And so when I do sum of the forces on both, I'm going to pretend that these masses are one complete system as they move together. So with that in mind, this guy has tension, this guy has tension, this guy has gravity, this guy has gravity. But the tensions are going to cancel out when I'm looking at the whole system. So for this scenario where I'm looking at the whole system, those tensions are equal and opposite and they cancel each other. So what I'm left with is force of gravity 2 minus force of gravity 1 equals m1 plus m2a. So let's put some numbers in and see if this makes sense. Let's put in simple numbers. Let's say he's 1 kilogram, and let's say he's 2 kilograms. If that's the case, then what's this guy's weight? Well, he's going to be 1 times 9.8, so he's going to be 9 point. Actually, let's, just for the sake of arguments, this goes a little faster. Let's use 10 for gravity. So the number will be off by a little, but you'll get the idea. So we can do this in our head now, right? This is going to be 10 newtons. This, gravity. Sorry, this is supposed to be a G, gravity. So back to blue. So this guy's going to be 2 times 10, this guy's going to be 20 newtons. So if I come up to here, I've got positive 20 newtons because my positive, for him, positive is down. And then for him, positive's up, so negative 10 newtons equals, and my two masses added together is going to be 3 kilograms times A. So what do I get? I get positive 10 newtons divided by 3 kilograms equals A. So my acceleration is going to be what? 3.3 meters per second squared. So what I can do, so that's finding the acceleration, and I ask you that in a quiz. And then the other question usually is, well, what is the tension? Find the source of tension. And we can use either block to find the tension. Let's say we use block 1 to find the tension. I have the force of, for him, I have the force of tension positive minus his gravity equals M1A. So I'm going to look at just him, right? So I don't want to be standing in front of it so the camera can't see it. So I'll put it over here. So what do I get doing this guy? I'm going to get the force of tension, that's unknown, minus gravity, which for him is 10 newtons, equals the mass, which is 1 kilogram, and the acceleration we just found, which is 3.3 meters per second squared. So what do I get? So this is going to be 0.3 meters per second squared divided by 10 newtons. So that's the force of tension. So force of tension is going to be 0.33 newtons. That's wrong. That can't be right. What's my mistake here? Oh, it's not divided, it's subtract. Yeah, sorry, going a little too fast here. So what do I get? 3.3 minus, so it's going to be plus. Bring the negative to the other side. So plus 10, so I get 13.3 newtons. Yeah. So this is 10, and this guy here is 13. So it makes sense because he's going to accelerate upwards. And I could do it on the other side. Because I used 10 for gravity and not 9.8, they won't be equal, but they'll be close. So this tension's around 13, and I don't know, if I'm going to get around 12, around 14 for that guy. All right, I'm going to pause, and next I'm going to talk about the elevator problem.